In this video, we're going to go ahead and explore more about planes. So I've got a plane graphed here, and we can see that the equation for that plane is 2x plus 3y plus 4z is 10. And I want to look at sort of the points and the normal vectors and how we can use those to look at the plane. So I've written it in this form where it's sort of hard to read off a point, but I can notice that if I let x equal 2 and y equal 2, then that already gives me 2 times 2 is 4 and 3 times 2 is 6. I add those, I already get 10. So then if z is 0, that point should be on the plane. So let's check that. I'm going to use the point 2, 2, 0. And I can check, that gives me that nice point A there. That is a point on the plane. So that's the point I'll use for my point on the plane. We can check now the normal vector. So remember, if I use a lowercase letter and I type in a point, it's going to actually give it to me as a vector, 2, 3, 4. That's actually going to give me that direction, which is orthogonal to everything in that plane. But what I would like to do is I'd like to actually redraw this vector so it's actually starting at that point A, because I think that makes it nicer to picture. So I'm going to go ahead, and the way I do this is I type vector. I put it in the starting point, so that 2, 2, 0. And now I put in the ending point. So I'm going to add that 2, 3, 4, 2, 2, 2, 0. So I get 4. 2 plus 3 is 5, and then 4 plus 0 is 4. So you can see I've just now shifted that vector over, so it's sticking out of A there. So I'm going to get rid of the original one that was starting at the origin. So there's my point and my normal vector for that plane. Now the way that this plane is defined is that any other point in the plane, if I find the vector between that point and A, then the vector should be orthogonal to my normal vector. So let's actually check that. I'm going to pick a point, and Geogebra allows me to just click on point, and then I can click on this object, and that's going to give me this nice point B, which is always stuck inside that plane. And then I'm going to draw a vector. So I could type in vector and then put the 2 points, but I'm just going to go ahead and click. So I'm going to start at A and go to B. So now A was a point in the plane and B was a point in the plane. So the vector between them, this black vector here, I'm going to go ahead and just make that a different color so I can refer to it by its color. So maybe we'll make this the green vector. That green vector is a vector in the plane. And I can move it around, that B, to any point in the plane, and I get all of these vectors in the plane. So what should be true now is no matter which point I pick in my plane, that green vector, that vector in the plane, and the black vector, the vector that's orthogonal to the plane, that normal vector to the plane, those should always be at a right angle. So let's double check that. I'm going to go back to Tools here, and I'm going to ask it to measure this angle for me. So I'm going to go down here to the measure section and click on angle. And I can select either 3 points or 2 lines. Let's see if it'll let me select these 2 vectors. It does. So there we go. So now I can see that the angle between those two is 90 degrees. And in fact, if I move this to any point that's on that plane, then I'm always going to get that 90 degrees. So that's how that works. For any point on the plane, if you take the vector between that and the point A, that's going to make a 90 degrees angle. In fact, I could pick another point on the plane. So let me make another point here. It'll also be on this plane. And I could find the vector between here and here. And this new vector also makes a 90 degrees angle with that normal vector. It's a little harder to see because the normal vector isn't sort of starting in the same spot. When we want to look at angles between vectors, we often want them to start at the same spot. But I could move this vector over. So I could say I want to make a new vector, have it start at B, and it's going to end at sort of B plus my normal vector. Let's see if that works. Yep. And so that's a new location for the normal vector, but again, same magnitude, same direction, so it's the same vector. And now we can see, again, if we go to the measure tool, that we really do have the angle between this vector and this vector, the normal vector, and any vector in my plane. It doesn't matter what I do, no matter where I move these, the angle between vectors in the plane is always going to be, oops, 90 degrees. I started moving that A off of the plane, and that's where I ran into trouble. But as long as I move it around so it stays on the plane, then it works. Okay, hope these helped you kind of visualize things. Let me know if you have any questions.